Hello friends, good morning all of you. Here I am Gadekar Sachin Pandit. Okay, today we are discuss about periodic table and periodicity of elements. Okay, so in this chapter we are discuss long form of periodic table, features of long form of periodic table, then merits and demerits of periodic tables. And lastly, we are discuss a classification of elements. Okay. So last lecture we are discuss about the relative energy of element, relative energy of orbitals. Okay. So these relative energy of orbitals depends on the presence of electron. They present a single electron. At that time relative energy is depends on the principal quantum number n. Okay, if atom consists multi-electron atom system, at that time relative energy of elements is depends on relative energy of orbitals is depends on both principal quantum number as well as azimuthal quantum number. Okay, so this relative energy is depends on principal and quantum number. Okay, so today we are discuss a long form of periodic table. Okay, so first periodic table proposed by Mendeleev. Okay, so Mendeleev's periodic tables in which Mendeleev's periodic tables had many drawbacks. Okay, so Mendeleev's periodic tables is based on weight of atomic number. Okay, and which is the variable property. Okay, so in this picture we are discuss on Mendeleev's periodic table. In this periodic table, helium, neon, argon, krypton, these are the inert gas element and they placed first. Okay, zero group element, then first group, second group, third group, fourth group, sixth group, seventh group, and lastly 8 groups element: iron, cobalt, nickel, which has similar property and they included in same group elements. Okay, so this is the periodic table of Mendeleev's. Okay, so these periodic tables overcomes on the long form of periodic tables. Long form of periodic tables which is proposed by Moseley. Okay, so this is the modern periodic table of elements, also called a long form of periodic tables. Mendeleev's long form of periodic table which is proposed by Moseley. Okay, so in this periodic table there are different groups and periods. Okay, so a vertical column is called groups. There are 18 groups and 7th period. Okay, horizontal line. Okay, 1 2 3 4 7, this is the period. Horizontal line is the period of periodic tables. Okay, so these periodic tables again classify in different blocks: S block element, D block element, P block element, and last on the bottom of the periodic table is the F block elements. Okay, so Mendeleev's First, we are discuss a Mendeleev's periodic table. These Mendeleev periodic tables had many drawbacks. Okay, so these periodic tables was based on atomic weight, which is variable property. Okay, so in Mosley's periodic table, Mosley's modern periodic table is based on fundamental properties of atomic numbers. Okay, Mosley's periodic tables is based on fundamental property of atomic number, and it shows that physical and chemical property of elements are the periodic function. Okay, so in this, increasing atomic number is depends on the protons, and protons ultimately increase the electron. Okay, so this periodic table is depends on the atomic number. Okay, so various elements with similar property repeat after a regular interval with increasing atomic number. This is the properties of element. This similar property is repetitive, resembles after some interval or a regular interval with is increasing atomic number in periodic table. Okay, which is called a periodicity of periodic element. Okay, so in this slide we are discuss in modern periodic table. In the modern periodic table, the elements are arranged horizontally in order of increasing atomic number. In each element is identified by symbol. Okay, element represent by symbol. Okay, so also including in mass. Okay, so long form of the periodic table is also arranged based upon increasing proton and ultimately increasing electronic configuration of element. Okay, so in this slide, first we are discuss a modern periodic table of elements or long form of periodic table. These periodic tables has 18 vertical column. Okay, so first, second, third, fourth, 18 vertical column is called a group. Okay, so 7 horizontal rows are also present. Okay, in this horizontal row is called a period. Okay, so in this modern periodic table consists 18 vertical groups. Okay, 18 groups and 7 periods. Okay, horizontal line is called a periods. Okay, so element of group in this table, element of group first, second, 13, 14, 15, 16 and 17 is called a main group element. Okay, so element of group first, second, 13, 14, 15, 16, 17 is nothing but a main group element, or also called a representative of elements. Okay, so the elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is the transition element. Group 13 to 12 is known as a transition element. Okay, so the element of 18 groups in this diagram, last group, are also called a zero groups element or inert group elements. Okay, so element of group 18 is called a noble gas element or also called a inert gas element. Okay, so first group in first period. Okay, so left hand side, first group and first element, hydrogen atom. Okay, so in this first period, okay, first period consists a hydrogen and helium atom. Okay, so left hand side we see we can see hydrogen and helium. The first period contains only two elements and it is a shortest period of the periodic table. Okay, and second, lithium, barium, boron, carbon, nitrogen, oxygen. Second group element such as lithium, barium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so this is the 18 elements. Second group elements is a shortest period. Similarly, third group elements, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. So this is for second and third period contain 8 elements and which is the shortest period element. Similarly, fourth group element. Okay, fourth, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, etc. So this is the fourth group element and fifth group element is the rubidium, strontium, ytterbium, zirconium, neodymium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, indium, tin, etc. Okay, so these fourth and fifth period contain 18 electrons, 18 elements. Fourth and fifth contains a 18 elements of each group and this is called a long period of the periodic table. Okay, similarly sixth groups, similarly in seventh group, sixth and seventh group. Okay, six, cesium, barium, lanthanum, hafnium, tantalum, tungsten, etc. And which is the longest period of the periodic table. Okay, fourth and fifth is the long period and sixth is the longest period in the periodic table and seventh is the francium, radium, actinium. This is the incomplete. Okay, in which consist a actinides and sixth group consists a lanthanide elements which is the F block element. Sixth group, sixth period is the longest period and seventh is the incomplete period. Okay, so group 3 and 7th period, there is the series of element which is the atomic number 89 to 103. They are known as a actinides. Okay, actinides. Sixth group, third B, consists a lanthanides and actinides. Group 3B. Okay, so now we are discuss a merits and demerits of long form of periodic table. Merits and demerits of long form of periodic table. First, the classification based on the atomic number. First merit of the modern periodic table is classify on the basis of atomic number of elements, and which is the fundamental property of atomic weight and position of elements related with electronic configuration. Okay, so this is the first merits of modern periodic table. Second, some group possesses same number of valence electron and it shows similar characteristics. Okay, so in modern periodic table, some group possesses same number of valence electron and it shows similar characteristics. Okay, so like the first group element. First group element consists a lithium, sodium, potassium, rubidium, cesium, etc. It shows a same number of valence electron and it shows similar characteristics. Okay, so these group elements belongs to the alkali metals. Okay, so variation of chemical property of the modern periodic table, variation of chemical property along a period is correlate with the gradual filling of electron. Variation of chemical property is depends on the gradual filling of electrons in a particular cell in the period. Okay, across the period, increasing one electron by each element. So this increasing electron in each element, it shows variation of chemical properties, and this variation of chemical property is correlated with gradual filling of electron in a particular cell in the period. Okay, so in inert gases, last right hand side of the modern periodic table placed in inert gases. Inert gases are placed at the end of each period. Okay, so because valence cells have octet configuration, complete the octet of each element. So inert gas are placed at the end of each periodic table because of valence shell electrons have complete configuration. Okay, so also explain inertness in modern periodic table. It depends on electronic configuration of atoms. Different type of elements have the different position. Okay, in the modern periodic table. Example, actinides placed in third B group. Okay, lanthanides, transition elements placed in between the S and P block elements, metalloids, non-metals, inner transition elements, actinides, active metals, transition metals, metalloids, non-metals, inner transition elements, inner transition metals. Inner transition metals nothing but a F block elements. Okay, so different types of elements have different positions in modern periodic table. So this is the merits of modern periodic tables. Okay, so some demerits are also included in these modern periodic tables. First is the first demerits, the position of hydrogen atom. Okay, so in modern periodic table, position of hydrogen atoms remain controversial. Okay, so in Mendeleev's periodic table also position of hydrogen atoms remain controversial. Okay, so its valence electron shows similar properties, both alkali as well as halide types. Okay, lanthanides and actinides could not be placed in the main body of the periodic table in modern periodic table. Okay, so this is the second demerits of the modern periodic tables. Okay, so it does not reflect exact distribution of electrons, some transition and inner transition elements. Okay, these three points are the demerits of modern periodic table. Okay, so this is the modern periodic table, and these modern periodic tables first propose a Mosley. Okay, so also called a modern periodic tables of Mendeleev. Okay, so in this modern periodic table is classified in different groups. Okay, also classify a different blocks: S block, D block, P block and F block. Okay, also divide a in group. Okay, first group is nothing but a, in this figure, first group is nothing but a alkali metals, second group alkaline earth metals, third to 12, third group to 12 groups are included in D block elements or transition element. Okay, so these transition elements again classify into three categories: first transition, second transition and third transition elements. Okay, so next is the P block element. Okay, so in these P block elements again divided in different classes. Okay, 13 group element, 14 group element, 15 group element, 16, 17. These 13 to 17 group elements is nothing but a P block elements. Okay, so last is the 18 group element or zero group elements or noble group elements. These modern periodic table divided in four categories: S block element, P block element, F block elements. Okay, so elements are classified in four groups: S, P, D, F block elements. First we discuss a S block element. Okay, so S block element in which last electron enters into S orbitals are called a S block elements. Okay, so again last electron, again these S block elements classify in two categories: first group and second group. First group is the alkali metals and second group elements is the alkaline earth metals. First group consists lithium, sodium, potassium, rubidium, cesium and francium. And second group alkaline earth elements, alkaline earth metals such as barium, magnesium, calcium, etc. Okay, so this is the S block elements. Okay, so why calcium is called alkaline earth metal? Because of it produce alkali solution. Alkali in water is called alkaline metals, and which is produce a calcium hydroxide. So we call a alkaline earth metals. Okay, so next is the p block element. Okay, so p block elements in which last electrons enters into the p orbitals and are called a p block element. P block elements in which last electron enters into p orbital are called p block elements. Outermost shell is ns2 to np1 to 6. This is the outermost shell electronic configuration. ns2 np1 to 6. The p block element consists group 13 to 18 elements. Okay, so these p block elements again classify in three categories: metals, non-metals, and metalloids. Okay, so and last is the 18 group elements or 0 group elements. Now we are discuss d block elements. Okay, so d block elements in which last electron enters into d orbitals are called d block element. Their outermost shell is ns2 n minus 1 d1 to 10. D minus 1 because it is a inner shell, and d block element consists group 3 to 12. Okay, so these d block elements again classify into three categories. First is the 3D transition, 4D transition, 5D transition, and 6D transition. 3D first series element or first transition series element consists scandium to zinc. Second series or second transition element, second series of elements ytterbium to cadmium, and third series or third transition elements is lanthanum to mercury. Okay, similarly fourth series, which is the incomplete series, it starts from actinides to mercury. And lastly F block, last electron enters in the inner penultimate shell. Last electron enters in p orbitals, that is n minus 2 f orbital, and this is the inner orbital, penultimate energy levels. Okay, so the last electron of electrons enters in f is called differentiating electron. Okay, so these f orbitals is highly diffuse orbitals. Okay, so and this electronic configuration is n minus 2 f minus 1 to 14 and n minus 1 d 0 to 1 ns2. Okay, so last in general electron configuration of the F block elements is n minus 2, principal quantum number 2, because it's inner transition element. F 1 to 14 elements are included. N minus 1 D0 to 1 and NS2. This is the last cell. So this is the modern periodic table, S.P.D. block elements. Just we are discuss on the modern periodic tables. These modern periodic tables includes a 4 blocks S.P.D.F and these classify in first S group alkali metals and alkaline earth metals, then transition element, first transition, second transition and third transition, then right side P block element, these are the three class metals, metalloids and non-metals, and last 18 group elements is called noble elements. So thank you for the watching this video. Now we are stop here. Next lecture we are discuss about the shielding or screening effect.